Welcome to video lesson 11.2 on graphing rational functions. Yesterday we learned about inverse functions, which was a type of rational function. And today we're going to be graphing more of those. Okay? So inverse variations are examples of rational functions. And a rational function is any function that has a form of y equals a polynomial divided by another polynomial. The important thing to remember is that the denominator can never equal 0 because we know we can't divide by 0 in math. The most basic rational function is the form of y equals 1 divided by x. Now keep in mind, just for the ease of making my notes on the smartboard, I wrote all the division in this form, but it will look like this more often in your book and any of the problems that you do. Okay, in other words, wherever I have the parentheses and the little division symbol, it really would be written in vertical form, not horizontal form. All right, now since division by 0 is undefined, okay, we can't do it, we would get an error message on our calculator, the value of the denominator of a rational function can't be 0. So the domain of a rational function excludes any values that make the denominator 0. And these values are aptly named the excluded values of the rational function. So in example 1, we're trying to find those excluded values for the function. And again, this would really be written in vertical form. Okay, just more difficult for me to write it in the smartboard that way. As y equals 2 divided by the quantity of x plus 5. So what we want to do to find the excluded value is we want to find the value of x that's going to make the denominator 0. So we write the equation. The denominator is x plus 5. We want to make that 0. To do that, we're going to subtract 5. So the excluded value of x is when x is negative 5. So x cannot be negative 5 because then the denominator will be 0, which is undefined for this function. Right? Now in example 2, we're going to graph one of the, and little close to the basic function y equals 1 over x, but it's y equals 1 over x minus 1. And then we're going to also describe the domain and range, typical to what we've been doing carefully. So what we want to do first is find what the excluded value is. Okay, so the excluded value is, again, when the denominator is 0, what the x value is. So we set the denominator equal to 0, and we solve for x. So the excluded value is x equals 1. So we're going to choose x values that are on either side of 1 and make an xy table. Okay, so whenever we're graphing rational functions, our first thing is to find the excluded value. Okay, and then we'll make our xy table choosing values on either side of that excluded value. All right, so I'm just going to pick -2, -1, 0. Okay, and then I'll do quite a few. Then I'll do 1 and 2 and 3 and 4. So that I have 3 on either side. So we know this is undefined or 0, which we can't do. Okay. Now, when x is 0, then we have 1 divided by -1, which would equal -1. Okay. When x is 1, then we have 1 divided by -1 minus 1 is -2, so it'd be -1/2. And when x is -2, then we have 1 divided by -3, -1/3. Okay. When x is 2, 1 divided by 2 minus 1 is 1. That's just 1. 1 divided by 3 minus 1 is 2. So 1/2. And 1 divided by 3, 1/3. And then we're going to graph those ordered pairs. Okay. -2, -1/3. And kind of just estimating this, -1, -1/2. And 0, -1. Okay. 1, 1. Okay. oops, sorry. Not 1, 1. 1 is undefined. 2 is 1. 3 is a half. And 4 is 1/3. Okay, so all of these are really close to 0 here and coming down. Remember, we're not going over the 1, so my curve has to go down so that it doesn't touch the 1 because that's the excluded value. Okay, and same thing going up this way, and it doesn't touch the y-axis either. Okay, and put our arrows there. And now we draw a smooth curve that goes through those points on each side of x equals 1. All right, so that kind of lets us know how to draw that. Okay. Now, we'll notice that in that last graph, okay, it approaches the vertical line, okay, x equals 1, but it never intersects it because we can never have x equaling 1 because then the denominator would be 0, and that's undefined. The graph also it approaches the horizontal line y equals 0, the x-axis, but it never intersects it. So the lines that these graphs approach but never intersect are called asymptotes. Okay, so an asymptote is the line that the graphs approach but never intersect. And it tells us here in this key idea how to find asymptotes when it's in the form of, and I'll rewrite it down here so it's a little bit easier to see, a divided by x minus h plus k. Okay, remember a can't be 0. And the vertical asymptote, okay, the vertical line, would be x equals h. So it has to be x minus h. If it would be x plus h, then it would just be x equals the opposite of h. Okay? And then k is the y, the horizontal asymptote, whatever that value is. Okay? So if it would be minus k, then it would be y equals negative k. All right? Let's take a look at an example of that. So what we want to do is we want to identify the asymptotes of this graph. Now again, I should, instead of writing that horizontally, I'm going to rewrite it vertically for you. Okay? That's what that will look like vertically instead of horizontally. And it says describe the domain and range. So our vertical asymptote will be x equals 2, okay, because it's in the form of a divided by x minus h, and x equals h is what the vertical asymptote is. So in this case, x equals 2. And y equals k, but normally it's plus k here, and so since it's minus 4, y is negative 4. Okay, and that's our vertical and horizontal asymptote. All right, now we need to find the domain and range. All right, so since the vertical asymptote is x equals 2, okay, that means the domain, okay, is all real numbers, okay, except, 2, okay, and the range then is all real numbers except, what do you think it's not going to be? Well, it's not going to be negative 4 because it never intersects that line at negative 4. All right. Now we have example 4, sort of putting it all together. Okay. Again, I'm going to rewrite this equation vertically. Okay. So now we're going to graph that, and then we're going to compare the graph to the graph of y equals 1 over x. Okay. The first thing we want to do is find what the asymptotes are. Okay. So, and then once we find the asymptotes, so we know one asymptote will be x equals negative 2, because normally this is x minus 2, then the asymptote would be 2. Since it's x plus 2, the asymptote, the vertical one, is negative 2. And y is 3. All right, so those are our asymptotes. Okay. And they're the lines that these graphs are going to come very close to but never intersect. All right. What we want to do then is make a table of values on either side of our excluded value here, which would be negative 2. which we could go back to the first lesson, excluded value here, x plus 2 equals 0, okay? And when we solve x equals -2, that's also your asymptote, right? And that's why it's your asymptote. So x and y, and let's do -4, -3, -2.5, -2. And then we'll continue on that pattern. Okay, -1.5, -1, and 0. All right, very good. Now, when x is -4, okay, we have 1 divided by -4 plus 2 is -2, so that's -1/2 plus 3, and that's going to give us 2.5. Okay, when x is -3, okay, that's going to give us 2. When x is -2.5, okay, that's going to give us 1. When x is -2, okay, that's our asymptote, and that's where it's undefined, because the denominator would be 0, okay, which we can't do. When x is -1.5, okay, then we get 5. When x is -1, okay, then we get 4. And when x is 0, okay, we get 3.5. Oops, I am kind of running out of room there, so 3.5 goes up here. Now we need to draw a smooth curve through the points, okay, to plot them on each side of our asymptote. Okay, so -4, 2.5, okay, -3, 2, -2.5, 1, -2 is our asymptote here. And on the other side of it, we have -1.5, which is 5, and -1, 4, and 0, 3.5. Okay, and again, the horizontal asymptote is 3. So we go here, close to -2, close to 3, but never intersecting. Same thing here, close to -2, close to 3, never intersecting. That's how we get those curves. Okay, now we have to describe how that's changed from the graph of y equals 1 over x. Okay, well, what has happened, very similar to when we're dealing with absolute value graphs or even square root graphs, okay? And it's going to be a translation 3 units up, okay, because of this plus 3 units up, and 2 units left. Okay, and again, because of this plus 2, we're always doing the opposite of what that is, so we're going to the left, okay, of the graph of y equals 1 over x. Okay, so now we've graphed it and we've compared it to the graph of y equals 1 over x. So the comparisons are very similar to what we've been dealing with when we have absolute value graphs or square root graphs, right? Now you have 5 practice problems. Okay, the first 2, you're finding the excluded value. So what is the value of x that will make the denominator 0? Okay. Number 3, graph that rational function. First, you're going to want to find the excluded values and then use that to be able to determine your x values in your table and graph them. Okay. 4, you're going to identify the asymptotes, which the vertical asymptote is just the excluded value again. Okay. And then use that to describe the domain and range. And 5, you'll use the asymptotes and then a table to help you with the table to graph and then compare it to the graph of y equals 1 over x. There's a lot of new information in this section. Please make sure you write down any questions that you've had and be sure to ask them during class. Thank you. Have a great day.